All right, and welcome back. This is Module 2 for C# Fundamentals. Welcome back, Darren.
Welcome back, Jerry. Are you nicely refreshed?
I'm nicely refreshed, ready to go.
Raring.
All right. What are we going to talk about in this module?
We're going to talk about constructing complex types. So how do we actually start to build out and use this wonderful type system in modeling types that help us solve problems? We're going to start talking about object interfaces and inheritance, so really driving into those areas and really exploring those capabilities. And then we're going to touch on generics, one of my favorite parts of the C# and .NET Managed Runtime.
Beautiful.
Okay.
I got to say it again, we're going to be covering so quickly these things that need a day each.
Exactly, yeah. Brief skim with occasional scary deep dives. You're going to love it.
Yeah.
Okay, so constructing complex types. We have two foundational ways of constructing a complex type. We have a class and a struct.
They're not the same thing.
They're not the same thing. That's why they're two separate words.
Oh, I get it.
It's awesome.
It's interesting.
So a class or struct defines the template for an object. So what do we understand by that as a template?
Well, we were talking about interfaces. Is that the same thing?
That defines a contract, absolutely. The difference between an interface and the classes and structs is the classes and structs actually implement behavior, whereas an interface just promises that that behavior will be implemented.
I see. Okay. Got it.
I think that's foreshadowing as well.
Yeah, so we're going to have to talk about that later.
So, what does a class represent?
Well, let's see. A class represents the entire body of functionality, right? If I have a person, it represents the entire person, both all the things we know about it, like its eye color and its name and things like that, so which we'll talk about as properties, but it also its abilities, right, which we'll talk about as methods, its ability to speak, its ability to do different things, and so we have those two things, as well as, and I know we'll get to it, events, and that's its ability to almost communicate back to us, right? Yeah.
So that sounds like it's pretty complex, and that's a lot of information. And it sounds like, you know, what we build in that would take up a lot of space in memory.
Yeah, no doubt.
So, you know, we probably want to employ.
Depends on the person.
It's very true. Very true. But we want to employ some way of managing what that memory allocation is and making sure that we're as efficient with that memory as possible. So that really is why we have reference types within the managed runtime. And so a class is used to define those kind of complex behaviors, and an instance of a class is a reference type, which is a pointer to where that object is.
So when we're talking about the person and it's all of its capabilities and features, am I talking about a class or am I talking about a struct?
Depends on how it's declared, because you could model a person as a struct, which represents a value type, but you want to be careful about when you use structs and when you use classes, and we'll touch on that in a little bit more detail in a moment. But a struct represents a value type, so every time we have an instance of a struct, we're actually saying we're occupying a chunk of memory for every struct that we're using. Whereas an object or a class can refer to the same object. And we'll touch on that in a little bit.
It's really about memory usage is what we're going to get to.
Yeah.
Yeah. There's that. So defining a struct is simple enough. The syntax around it simply says it's a struct, struct, and from that point forward, it's no longer a class, it's a struct.
Exactly.
It really is that simple, and we'll see that class syntax is exactly the same.
You're exactly right. And so if we flip over to a class, actually, if we talk about structs.
Yeah, let's get into a little more detail, because I want to talk about how what the implications are around memory.
So we just kind of mentioned that the idea is that a struct represents something that is more compact. Has a small number of members. Those members are generally value types themselves, and so the idea is that it occupies a fairly small footprint in memory. Or it's something that is commonly embedded within another type, i.e. it's internal. Perhaps you just bring it up whenever you create another instance, and so it just occupies a small footprint of memory. It's quick access.
And I'm hearing the trend, it's smaller, smaller, smaller. I mean, the more elaborate it is, you're probably going down the wrong track with a struct.
Exactly. You know, it typically represents a single value. Now, that doesn't mean it's just a single property, but conceptually it models something, such as a point. A point has an x and a y coordinate if we're talking in 2D space. And so a point struct has an x property and a y property.
So it has two properties, but logically it's a single value.
Exactly.
Yeah.
You know, the same thing with, say, you're defining a rectangle.
Right.
You know, you have an origin, X and Y, and you might have a width and a height. Again, conceptually, it's a very small value that you would reuse.
This would be extremely important if you have lots of rectangles.
Yeah.
Yeah, we'll talk about that.
Exactly. Typically, you want to make sure that these types are what's called immutable, which means they don't change over time. So you give it a value and you retain that value. That allows you to make certain assumptions about how you're going to use this. It's consistent. And if you want to change those values, in fact, you would end up creating a new type.
Yeah, and so if I'm interacting with a struct constantly, changing its values and all of the pieces like that, again, I might be going down the wrong track with a struct.
You might need to think about your strategy that you're using there. One other aspect is it's rarely boxed, and we'll talk about that in more detail, but it's a performance
Does this have to do with, this has something to do with Christmas? Boxing?
Absolutely. No, pugilism, in fact.
Ah, good. You know, Javier, I was just bringing it home.
Yeah, so basically boxing is, as I mentioned, something that we need to consider for performance. One of the key reasons you would use a struct is if you're doing a lot of computation expensive activities, the abstraction of having a reference type introduces additional steps if you want to access and manipulate those properties. So if you're doing some very intensive math computation, you may wish to use structs instead of classes, because that is just going to be quicker. And if you're iterating through that many, many times, then it will be faster access. The flip side is there's a memory concern if you're creating structs continually within one of those loops.
All right, so let's talk about classes now. So obviously I'm going to create something that's going to be, say, a little more elaborate. I'm going to interact with it. It's going to hold more data, maybe a series of points. Now I'm headed towards a class instead of a struct.
Yep.
And a class, we see the syntax. The syntax is just as simple. Just create it and start implementing on the inside of it. A class is special, it is a reference type, and to be different, a reference type is a pointer.
It basically points to the location in memory where that object instance is stored. And where that becomes powerful is we can have multiple references to that same object without duplicating that object's definition in memory.
So if I have a single dog, let's say that's my class, and I say there's the dog, and there's the dog, and there's the dog, and there's the dog, I've got 4. But in reality, in memory, I have 1, and all 4 of those are pointing back to the same one.
Exactly, and that's very efficient, especially if we start moving things around and passing them as arguments to methods.
And by contrast, if I had a struct and I said there's a dog, and there's a dog, and there's a dog, and I have 4 dogs now.
You have 4 dogs, and there's no relationship between those once you've created them.
Yeah, that's right. They don't know about each other, and certainly manipulating one doesn't manipulate the other 3. Where if I manipulate the first class of dog, because it's a reference, I'm actually updating the one and only reference of it. And so all of them get updated at the same time.
Absolutely. So there's some interesting things about a class in terms of you can decorate it and describe exactly what type of class it is. So you could turn around and declare animal is a static class.
Static class. Now this is interesting because I think we're probably going to be talking about invocation or instantiation, and that is to create the actual instance of a class.
Yeah.
Static is not doing that.
Static, you can't do that. It's actually, the compiler will prevent you from creating an instance of that class.
Why would you possibly do that? Why would you create a class only not to be able to instantiate it?
Because you can expose some static methods on that class, and so you can then just directly interact with those things. And what's key about that is there is no state being managed within a static class. It is effectively stateless. It just provides you with a series of behaviors.
Almost like a library of interactions and activities that it can do without the cost of instantiation.
Exactly.
Yeah. I like it. That's static. We can also choose from abstract. And abstract, just like static, cannot be instantiated.
Exactly. But the key difference here is the abstract class is actually an incomplete class. It may define behaviors that need to be implemented by anybody that inherits from that class, but it effectively is incomplete. It basically states that we are creating a template that needs to be inherited. Now, and we'll be demonstrating a lot of these capabilities shortly. We'll be bringing up a console application and going through some of these abilities.
And so an abstract class is important because it kind of goes back to the dog. If you have an animal and it inherits from, and you have a dog and it inherits from animal, nobody is going to instantiate an animal because there's no such thing as an animal. There's only a dog and then a cat, right? That's what really is there. And so you would mark those as abstract. BitLocker I rebooted, but it asked me again.
Okay, and then the final kind of modification we can place on a class is we can turn around and say it's sealed. And so sealed is one of these almost paranoid things you can do to a class. You can turn around and say, this class definition cannot be extended, nor can it be inherited from. And so you turn around and say, I have absolutely nailed this specification of this object, and nobody else will be able to go in and extend it any further, except if we use
extension methods are right, but it's still
don't break encapsulation.
They do not break encapsulation, and it doesn't make available some of the internal data, right? It just adds to the functionality.
Yeah.
Let me show you something interesting. So when I create a class, and so this is I'm going to create a quick class here in a file, and let's call it dog. And so if it was dog, and I'll call it dog1 just to make the point here. One neat thing I can do with a class is I can mark it as partial. And this is important because a class definition could be extremely large. And the reality is you and I may work on the same team, and you're working on the part of the dog that walks, and I'm working on the part of the dog that talks, which is a lot harder.
Yep.
And the reality is, because it's one file, Visual Studio is amazing, but it still is one file. We could overwrite each other easily. So what's cool is I could create a second file over here. And let me change it back. This is just dog. It just happens to be in a file called dog1. And if I created a second file, I could call it dog2. This is important because now dog2, I'll change this back, and I'll also mark it as partial. Now because they're inside the same scope, and that scope is its namespace, that's one class. Is spread across two files. You can go into dog1 and make all of your walking logic. I can go into dog2 and do all the walking logic. It's not two classes, Darren. It's one class, and the compiler knows what we're doing. And when it comes to actually compile my application, it becomes a single class again. But it allows us at dev time, right, to be able to be much more productive. I don't have to wait for you to finish walking in order for me to start implementing talking. It's very nice.
That's awesome. But I think there's another really useful scenario for partial classes, and that's when we're using something like, say, Entity Framework, which generates a lot of classes for us.
Yeah.
One of the great things about those types of tools is they generate code that we can use. If we didn't have partial classes, how would we be able to put additional behaviors in there?
Well, now that you mention it, man, if we didn't have code generation, imagine how much typing we'd have to do,
exactly.
Right? And we know the Visual Studio uses T4 templates to create most of that for us, and of course Entity Framework leverages that as well. But you say, you're right, it generates those classes, but the important part is it generates over and over and over. And so if we have our class definition that it's generated and we go in and tweak it, it'll just override all of the changes that we did, right? Because it is generating over and over. Partial classes allow us to cut it in half and say, don't overwrite my changes because they're in this file. We don't even have to tell Entity Framework or whatever code generation piece we have about it. Yeah, that's a very valuable piece. And I actually meant that earlier when I was saying I was going to implement talking, because I wouldn't actually write it. I would just
you just generate it.
Yeah.
Okay. It was great that you went into Visual Studio there and showed some code. We just want to point out that the first module was very introductory, and that's why we had a lot of slides. Moving forward, we're going to be in Visual Studio a lot, demonstrating some of these key code concepts and so on. Just want to make sure that's clear.
Now, so let's look at dog again. So I've marked it as partial, but look what else I can do. I can mark it as public. And so public has a special meaning, right? I mean, we're going to go through all of these different keywords, and the core piece is public allows me to create a class, or its members can be marked as public, and public is a special keyword that says anybody can see this. If you're referencing my assembly, if you're referencing my code, public means this is for you. Go, right? And then it allows me, it's basically around that wall of encapsulation, I'm now identifying where the windows are. So if I were to go say there was a method, say let's avoid, you like foo or bar?
Let's go foo.
Okay, so if I had a method, let's say, called foo, I could mark it as public as well, which means come use me. But I could also mark it as private. How is private different from from public?
Well, private really impacts the scope of availability of that method. Where can it be used? So if I declare something as private, I can only use it within the context of the dog class. So another method in dog could call foo.
Yeah.
However, anybody external to the foo class or the dog class cannot see foo.
This truly is the beginning of encapsulation, where I say, this is the black box, stay away, nobody can ever see foo. You instantiate dog, dot, and foo doesn't show up.
Exactly.
But let's say I have bar, and I do want it to show up. But public is really too public, right? I want to make it a little bit more constrained. What are my other options?
So if you want to be able to refer to it within the same assembly, you could mark it as internal.
Internal, all right. And inside the same assembly is an interesting way of grouping, right? So how far out does an assembly go?
So an assembly it's effectively scoped to a project in Visual Studio. So each project generally produces an assembly, and all your code gets compiled into that, and so that would be your assembly scope.
Makes sense.
Awesome.
All right, so what else can I do here? Let's say, it's possible that dog isn't dog. Maybe it's, I'm going to have a dachshund class that inherits from dog.
Okay.
Be even more derived. And so I
have short legs.
I don't know how to spell dachshund correctly, especially with
So use poodle, because I'm sure you're familiar with poodle.
Yeah, what? All right, let's say it's poodle, and the poodle inherits from dog. Now this is nice. So now that it's dog, if I did have, let's say it had an X method, in there I could say this dot, and I get, because it inherits, right, we get from dog, I get bar, but I don't see foo. Right? Foo is not there, and the reason is, foo is marked as private, only this class, not even the ones that inherited. It really is the black box. But what if I wanted to just open the door a little bit there?
Yeah, I think, a poodle should be able to foo. Good job you said foo.
It seems so.
Exactly. So basically we can mark out a method that's in the base class as something that derived classes can inherit from. And the way that we do that is we specify that it is protected.
Pretty cool. All right, so now I go down inside the poodle and I say dot, and I can bar. I changed it to bar so we could keep foo as a private option.
Okay, that sounds good.
So now I have one more. Now it's nice. It's not opening it wide to call it public so that anybody can see it, but it certainly is opening up to say, if you're going to use this as a base class and you're going to be inheriting from me, you're going to probably need this. I often include protected a protected event for raising events, right? Because you can't raise an event on a base, but you can call a method that does for you in the base.
Exactly.
When I call bar, is it executing inside the poodle or is it executing inside the dog?
Basically, it's executing within the object, and the object is both.
That's right. There is no dog and poodle. There is one object that inherits capabilities.
Exactly.
Excellent. All right, so that's interesting. We can do that to it. And
why don't we give the dog a name?
Let's give the dog a name. Now, do we want all dogs to have a name?
I think so.
I think so too. So I'll put that up in the base class. And what do we put there to hold the name? A variable?
You could create a variable. That would be an example. Now, what we need to decide is this name going to be publicly consumed, or is it going to be private and encapsulated within this class?
Yes. So we know it's going to be public because this is a dog, and the name is right there.
Exactly. And so the way that we encapsulate values to be shared externally is we use the properties.
Excellent. So I'll put out a public property in the dog class. It'll be a string, and it'll be name right there. And I see a get and a set in that property. What does get and set mean? We haven't seen that in the syntax so far.
Absolutely. So basically, the get and set instructs the compiler to create an infrastructure for us that will manipulate and store the value of name. So what we have here is a shorthand syntax for simple field access that will create behind the scenes a backing variable that will store name.
I'm glad you said that because I took a shortcut here for sure. I defined a property with a get set, and the compiler will blow that out to be the full implementation.
Yeah, why don't you do a full one?
Yeah, let's do a full implementation. Okay, so here's the full implementation. And what's special about it is not just that it has a get and set, but it also has this private member.
Okay, what do we call that? I think backing store?
A backing store, that's exactly right. So you're going to set the name, and in fact, I should have made it a string here, and we'll call it a, let's see, name, N-A-M-E, that's right, and we'll call the property. The Windows key here tricks me.
It does?
It does, but it's because I'm trickable. All right, so we'll call that name, and all right, so this is the long form implementation of a property. Why would I do this? It seems to me that the shorthand form is better, right? Because it's less code. Earlier we were saying less code, more maintainable, fewer bugs.
Absolutely, and I think that's why they introduced this syntax. But the longhand version gives us the ability to actually change the property to string, and
we're all debugging in our
exactly.
heads. Just show off the syntax.
I know, we can't help it. It's code. It's like we see those wiggly red underscores and we have to fix them. So, but what this allows us to do is additional actions whenever we're interacting with this property name. So we have the ability to extend the getter, which is fundamentally a method that interacts with the backing store. And not only do we say return the name when we say get, we could also initiate some other actions, such as do some diagnostic output right to the console.
Right. So if I have a setter coming in here, one of the things I might want to do is look at value. And that's the reason I might blow it out a little to say, if you're going to try and set the name, you can't set it as something.
Yeah, you might want to validate it. Oh, is that foreshadowing?
We'll have to talk about that later.
Exactly.
Excellent. All right, so often you'll see properties as that shorthand because it really is just holding a value. One interesting thing, can I do this? Can I put a keyword like this in the setter?
You absolutely can, and that's pretty powerful because what we're doing here is we're suddenly becoming very expressive with the encapsulation of this class. What we're turning around and saying is, in this scenario, for whatever reason, we are stating that you cannot arbitrarily, during the life cycle of this object, change the dog's name, which actually seems like a really good idea because Fido is going to get confused if you keep changing his name.
That's right.
So what we're actually saying is the scope of the name is shared publicly for consumption, but can only be created from within the class itself.
So we know there are three basic pieces to an object. We know that it has properties, which we're looking at here, and we see methods, which we can do, and we also can have events on them as well. The keywords are changing from one to another. Public is public, or what is it special when I get to events and when I get to methods?
No, that basically specifies the accessibility of all of these objects in exactly the same way. So if you have a public method, a public property, a public event, then they're publicly accessible. Same with protected and so on.
So foo is pretty simple, right? It's the classic demo here. But what if I were to create a more sophisticated method? What if I were to create a method that I needed to pass things to, a method that maybe even gives me something back? We can create something complex around that. Let's build something out for that.
Sure.
We've got a dog. A dog is going to speak.
Okay.
Good enough for you?
Sounds good to me.
All right. So we'll make it public because a dog, I guess, can speak. Anybody can tell a dog to speak.
Yep.
Huh, they really can, too.
They can.
It's really neat.
Yeah, they're often disappointed, but I think...
So now, a speak is not going to give anything back. It's going to cause something to happen.
Exactly.
So we'll mark that as void. But void is special. What does void mean?
Void basically means that the method doesn't return any value whatsoever.
Okay, void, nothing.
Nothing.
That's telling you what it returns.
Yeah.
Nothing.
It is very expressive, that's for sure.
All right, so I wanted to speak, let's say I wanted to speak something specifically. How do I pass it into it?
So then we would specify a parameter
Okay.
on the method signature. And the syntax declares that we would place that within the parentheses.
So I might pass in what it's supposed to say.
Exactly. And
so
so what you've done there is said that what is a string.
And the only thing you can ask it to say are strings. You couldn't ask a poodle, let's say, to say a decimal.
Not without doing some form of conversion.
You would be a YouTube hit.
Yeah.
No doubt about it. All right, so here, this is going to be to do. It's a complicated thing to get a dog to talk.
It's a complicated thing, and you don't have code generation running right now.
I don't, not yet. Right. Just right-click, go. That's exactly right. And so that's very powerful to me. Now, what if what people ask dogs to speak is always the same thing? It's very redundant. I'm appreciative of C# making me productive. How could I make other developers productive? Right? Are we not? Oh, with defaults. I jumped ahead, but let's do it anyway.
Exactly. Why not? Go ahead.
Yeah.
So basically, if you're passing in a common command and you want it to suggest to the developers that this is a standard way of utilizing it, and you want to give hints around it, you could specify a default value for that command.
Which is easy enough as just saying equals in the actual signature of the method.
Yep.
All right, so you might say bark, right? And that's the default what you ask a dog to speak.
Okay.
Anything else would be amazing.
It would be pretty good.
Not bad. So, although I've heard that dog that says I love you. Have you heard that one? The dog. I love you. You've never heard that?
No, I have not.
I love you. Never heard that?
I believe you.
I think it's a dog.
I believe you. Thousands wouldn't and probably don't, but...
Have you ever heard the goats that scream? They're equally hilarious.
Okay.
Oh, man.
Yeah, you spend much too much time on YouTube, apparently.
Oh, well, it's a learning experience. That's right. That's right. All right, so now my dog can speak, and the to-do will implement it here for us. All right, so let's talk a little bit more about method signatures and make sure we understand parameters. So I have created what we're passing into this method, and that is an argument.
The value that you pass into a method is an argument, yes. When you specify a method, you can specify its signature, which includes the parameters that method receives.
So the signature is a method that doesn't return anything, named speak, that takes a string.
And is publicly accessible.
And is of course, yes, and is publicly accessible. That really is the signature that makes it unique. I couldn't have another method that's identical to that in the same class.
You could not, because then for the compiler's perspective, that would be ambiguous. So ambiguity is measured based upon the signature of your class, or of your method, I should say. However, you could implement it if you change the signature. So how could we change the signature on this one?
Well, I suppose I could have another method, well, I'll just have it right below it, also called speak, but I want to make it different. And maybe I say integer times. How many times is it going to speak?
Yeah, that would be awesome. And
so this doesn't conflict because the signature is really different.
Exactly. I mean, you can, if you go up and show how
now, I'm getting a compile error only because we were showing off defaults. Let me reverse the order so that the one with the default is last, which is important because that's the syntax. You can't have defaults preceding others that are required.
Exactly.
And that is the difference. A default is not required. It's optional.
And that is a key point, and it's a very powerful point with a lot of these things. So why don't you go up and just show how these methods look like when you're consuming them and you're calling them.
You got it. So let me go down. I'll go to the poodle.
Okay.
Because the poodle is our dog of choice. All right. So now I can say this dot, and now I could say name. Of course, I did it both the long form and the shorthand. That's why there's a conflict in that. But now I have speak. But it only shows up once. I defined it twice. The compiler is clearly broken.
No, this is part of the power of the language. Now, if you actually start to implement it, what you will see with IntelliSense is it's detected that there are two implementations of speak which have different signatures.
Yeah.
And so you will actually get the option to choose which signature, just to hint which one. The other key great thing here is it's actually showing you your default value, so that you know that you could just close that off. If you wanted to use the default value, then you could just choose to use that and implement it straight.
So if I say woof, it will not call the method we created that implements times.
Exactly, because it knows this matches the first signature, and I won't call the second one. But if you wanted it to woof twice,
yeah, I could just say 2 comma, just like that.
Excellent.
Yeah. Now let's say I had a third parameter. I'm going to go ahead and add another one here to bark, and it's going to be it'll be a Boolean of whether or not to sit while he's doing it. Okay. If that's all right with you. And we'll just say, usually they will, so we'll go ahead and do it, right?
Okay.
And now I'm going to go here, and I'm going to say, I know that bark is defaulted. I'll accept them both. Now what's interesting is I'm only passing one value into this.
Yep.
Which of the methods is being called now? Because this signature only has one, so I would assume it's this one?
but we were only passing a number, and so the integer doesn't match that string parameter. Therefore, the compiler is going to search to see if there is an implementation that it can use, and so we'll therefore use the third one.
So we default to this one, or we call this one because of the defaults that are being kicked in. Actually give it several signatures.
Correct.
Yeah. And so what if I wanted to call times, Darren, but I did not need to change what? But I did want to indicate whether or not the dog should sit while he's speaking.
So you could do that in the longhand way, which would force you to supply the value.
Like this?
Exactly, which is inefficient. Or we could use named arguments.
Okay, so I just want to pass in true, and I assume it's like this. Of course, we know that fails.
We would know that that fails because that doesn't match any of the signatures.
That's
and
right.
You can't derive it. So you need to pass a name.
All right, so I can call sit.
Sit.
So I can call sit specifically like this. Now I'm bypassing what it's supposed to say, and I'm jumping directly over to sit.
Yeah, that's pretty powerful, isn't it?
That's unbelievable, actually.
Yeah. What if you swap those around? Could you
change the order?
Change the order?
Oh boy, watch this. We're going to wreck the whole system. All right, so I'll go in and I'll take which really should be at the end like this. Now we'll see that it doesn't work. Oh. Name parameters don't care about the order.
That's pretty clever.
Yeah, that's very good. Whoever wrote whoever wrote C#, not bad.
Yeah, they knew what they were doing.
Yeah, we'll give them 1 point.
Exactly. 1 point.
That's right.
For Gryffindor, yeah.
For Gryffindor, says the voice in the back.
Nice. Okay. Let's see. We talked about default value. Default values. Oh, we were kind of going back and forth actually around value and parameter. And I think just to double up what you were saying, sit is the parameters, is the method's parameter.
Correct.
True.
So from the concept of from the perspective of the method, those are the parameters.
It is a parameter. True, on the other hand, is the value of that parameter.
Correct.
It is the argument.
It is.
And so we have a parameter has an argument, and a method has a parameter. It's an interesting little syntax candy right there.
It is.
Yeah, no doubt. Can easily misspoken by me over my entire career until recently. So,
so why don't you add an event?
Let's do that. So we know there's two things that a class can do: both hold data in a property, do something, and raise an event. So what should we call it? I'll call it, first I'll make it public because I want an event. We know that event is called an event, E-V-E-N-T, and it needs a handler, which we'll talk about in a minute. And let's say has spoken, if that's all right with you.
Sure, that works for me.
Done. That's full implementation.
That is awesome.
Yeah.
It's incredible.
It's stunning.
So what is an event?
So the event is the way for a class or an object to talk back to me. So I can invoke.
What, like the dog is talking?
It's similar to how the dog is talking, but the dog is only speaking here because I invoke it to do that. But something could happen at any time, and an event will be raised as a communication mechanism back to me so I can handle something. That's why we have an event handler. An event's very tricky because its timing is known to you because it happens after something. But there could be many things in between when it was raised and when you actually began handling it. Let's talk about how handlers work, but first let me raise the event.
Sure, sounds like a good idea.
So we know that if you call speak, has spoken is going to be called. So I'll say, you call it just like a method. Has spoken, and I'll pass in this as the reference to the object that sends it. This is the class that sends it. This is the keyword that represents the current class. And then I pass in some event arg because I took the most generic of all of them, event handler. There's nothing to pass in. So I'll say event args dot empty. And now I've raised that event. So you call speak, and then it does whatever in the to-do line. And now, when it's finished, has spoken will be raised. And now I can respond to that. I can handle it. I can do whatever needs to be done after it's. Maybe I have to make him speak again.
Is that a safe way of implementing?
It's not. It's not at all. Because what if nobody is listening? That's a very important piece. That has spoken is now an event that if anybody's listening, I'm going to raise it and you can hear it.
So if nobody's listening, it's a null?
It is null. That's exactly right. So I would get an exception here that says a null reference. So a quick check would be right here. If has spoken is not equal to null. So
nobody subscribed to it.
Nobody subscribed to it, right? That's nobody is listening. The technical would be right. Nobody has subscribed to it. So I could speak all I want, nobody will hear it. I get this null check, and it actually helps in performance as well, that I'm not raising events that are useless.
That nobody's listening to.
Exactly.
Okay, that's interesting. So this is like to be a little bit more formal, this is the publish subscribe pattern?
It is.
So that's an implementation. That's interesting.
Okay. Now we could be more elaborate, of course, because an event handler, what is an event handler?
I think it defines the shape of a method that the event expects to be handling when you raise it.
That's right. So in this case, the handler, it has to do with the two methods, or the two parameters that will be populating.
It just trips off your tongue, doesn't
it? When we raise the event, right? That's the event handler, and of course we can extend that event handler. We'll talk about generics later with a generic that we could say it's not an empty arg. We're going to be passing back interesting things. How loud was he? Was anybody there? All kinds of neat things that you could pass back to that event.
Yeah, and the key thing here is, the event handler is a delegate, which we'll touch on a little bit later on, but it's such a common pattern. That's why there is now a class called event handler that you can use, because it's very common to just turn around and say, this is the object that raises the event, and in general, you're more interested in the event itself than any particular information that gets passed in that generic sense.
A common one might be like data loaded, and so after data had been loaded, then you can go find the data. You don't need to pass it around with the event.
Yeah.
Sure.
And of course, if you want to be more specific, then you can define your own event handler syntax or signature and pass those around.
Yeah.
Okay.
That's pretty nice. Now, how many people can listen to an event?
I think more than one.
That's right. That's right. So if I have a dog out there and he's about to speak, and I have 10 trainers, all 10 trainers can listen for that event to be raised to respond to it.
Now, the difference between that scenario in encoding is they are passively observing. They're not doing something to listen to the dog. Whereas with events within .NET, you need to actually subscribe to that event.
Yeah.
And you can have multiple people subscribe to that event, and that's the broadcasting to multiple subscribers is multicasting.
And a subscription to an event is like a string. I tie it to that object.
Yep.
And from that point forward, there's a connection between the object that I am listening to its event and me.
Yeah. Do you want to show quickly how to subscribe to an event?
Yeah, absolutely. So let's say I'm going to need an outside object here. So let me create another quick class of a trainer. And the trainer is going to, there we are, sorry, is going to, let's have void x again here. It's an excellent naming convention, by the way.
It is. It requires a huge amount of thought.
Let's change it to something that's more interesting, like let's not. Operate. It's going to operate. This is how a trainer operates,
okay.
Darren. I don't know, have you ever seen a dog trainer?
But that's fine.
All right, so let's do it then. So he'll have to create a new dog.
Yeah.
So I'll say var dog equals new dog, new poodle. So I want a real dog.
Okay. And the interesting thing is we can create new here, so we're seeing how we can create a new object. Because they aren't marked as abstract, we can create instances of them.
I can, that's right. I can create a dog, even though one may not exist. I may want to go back to mark that as abstract.
Yeah.
Because I don't want people to create dogs, I want them to create poodles and dachshunds. Wonderful. Or whatever. All right, so this dog, now when I look at it, I can see that he has a has spoken event right here. I'm going to remove this so that I don't get that red X and it looks like something's wrong when it's not.
Yeah.
So here's has spoken, and so that is the event that I want to subscribe to, and the subscription is with a easy enough plus equals.
So what does that plus equals mean?
It really means add to, because as it turns out, an event is a list of methods that need to be raised back.
Okay, so it's like a shorthand.
It is certainly a shorthand. And if there was anything that Visual Studio gives us, it's the ability to be productive with shorthands, right?
Yeah.
Not only can I just put plus equals, but it also is listening to what I'm typing, can see that I just typed plus equals. And look, it's already suggesting that I just press tab to do all the work for me. So I will. Bam! Now it knows I need a method, and it's going to name that method for me called dog_has_spoken, where all the logic that's going to react to that event will be.
Okay.
I'll tab again. It stubs out that event for me, and it even stubbed out a not implemented exception so I don't get too lazy.
So how did it know what the signature of that method needed to be?
It knew because of the definition of the event. It's beautiful. We always go back to typing, don't we?
Exactly.
So now we can go back to where we actually define the event, and it is here that we said what the signature of the handler needs to be.
There's power there.
There really is, and it's neat because the compiler is doing all the work for us, seeing it all behind the scenes and implementing it for us, just making sure we don't do it wrong. Visual Studio, on the other hand, is helping us to go find that rather than say, okay, now what is that signature? I need to build it. It does it for me.
Excellent. So the next area that we're going to cover in a little bit more detail is object instances and inheritance.
Ah, nice.
Okay? So if we switch to the deck. So we've touched on inheritance, and you've obviously demonstrated the basic capabilities just there with
where a poodle inherits from a dog.
Poodle inherits from a dog. We also talked about the different types of modifiers we can place upon a class to indicate static, abstract, and sealed. So we show how that if we'd marked the dog as abstract, we could never create an instance of a dog, but we can create instances of a poodle.
If we had marked the dog as sealed, then poodle could never inherit from it because it is sealed, so it cannot be inherited from.
Exactly. We've spoken earlier about the idea of virtual methods, the idea that a virtual method can have implementations, but the key thing is we can change that implementation in the derived classes, which is an interesting...
It's very powerful, too. It allows you to really control where things are going to be run.
And so, if we kind of look at this inheritance hierarchy that we've put together here, so we have class 1, class 2, and class 3, and we have some code here that really outlines those classes. So we can see that class 1 implements string name, okay? Class 2 inherits from class 1, and we've seen that syntax from Jerry's demo earlier on. Class 2 also defines a property called age.
So now we have two properties.
We have two properties. And class 2 has name inherited from class 1 plus age that is defined itself.
Class 1 does not have age because it's up the hierarchy, not down.
Exactly. And then we have class 3 that inherits from class 2, which means it gets all the crunchy goodness that class 2 defines, plus it also defines its own property called address. So if I was to create a new class 3, I would have an object that has 3 parameters, or 3 properties rather.
Right.
Name, age, and address.
And if you were to create class 2, you would only have 2.
Yeah.
Yeah, and 1 would only have 1. That's fascinating. Now, from speaking back to polymorphism, I could cast up that tree if I did have a class 3, and it wouldn't lose those capabilities, or it wouldn't lose those properties. But because I'm casting it up and treating it like, say, like class 1, I don't see those.
You don't see those.
They are still there. I've just cast it up to look like class 1.
To a certain extent, what we've changed is the publicly exposed shape of that object, but we haven't really changed the essence of what that object is.
Yeah, that makes sense to me.
So do you want to bring up the understanding the virtual override and new demo, number 37?
Yeah, let's do that. So I'm inside our project, by the way, and I think in the first session we were talking about you can go to xaml.codeplex.com to download it if you'd like to go with us. Wait, tell me the number again.
37.
That's how far down we really are. Is it really 37?
It is 37.
Oh, it's right here, yeah.
Yeah.
I think you were in charge of numbering the projects.
Exactly. I started back from infinity.
Took a while. Yeah. But I got it. I was determined.
It's awesome.
Right. I was stuck on infinity -1 for a long time. All right, so what am I looking at here?
So basically what we have here is a set of classes. We've got a hierarchy of those classes, and we can see down here how they're defined. So we have base class.
Base class.
Which defines a method called name. And we've marked it as virtual. Now virtual basically declares that our intention is that this method can be overridden by inheriting classes. It doesn't have to be overridden.
Yeah.
And the reason it doesn't have to be overridden is there is a body, there is an implementation there already, and the method is not marked as abstract.
So here is derived override. So this is going to be the poodle, so to speak, right?
Yes.
And we can see that it has gone ahead and implemented this method for us, overriding whatever was virtual here. So we're basically saying whatever's in the base class, throw that baby away.
Yep.
Right?
We are replacing that code block with the code block that now exists within this derived override
That is
class.
the power of override and virtual working together. All right, so
Exactly.
now we have another class, derived new, and I see it's also overriding. Oh, it's not overriding. It's new. What is this keyword?
So basically, new is telling the compiler that we are replacing wholesale the implementation of new, and that it is completely and utterly unique to derived new. It has no relationship with the previous one. We can't invoke the base implementation of
Okay,
name.
makes sense to me. And then we have one more called derived override.
Yes, now this is interesting in that we've
There's
created
no
one,
keyword here at all.
and there's no keyword at all. What we actually end up doing here is hiding the base implementation of the name.
I see.
And so we haven't said that we intend to replace it and you should obliterate it, but we've said that we are now hiding it just by virtue of declaring a name. So it's interesting that we're allowed to do that, because you think, oh, wouldn't that cause a problem? Now we do get warnings that suggest that we're hiding these things.
Because it is likely to cause a problem.
It is likely to cause a problem, and I would suggest using new if that's what you intend to do, so that it's much more declarative and speaks to anybody who maintains your code that this is intentional, not an accident.
So here I've created all four of these so that I can call that name in each of them. I want to see which one runs what. And so here I am calling all three of them. It's pretty interesting. Are they going to call the one that's inside their own class? Is it going to call the one that is in the base?
Why don't we run it and see?
Let's run it and take a look here. They all call their own. That's what we would have expected
That's
to
what
happen.
we would have expected.
Well, we haven't cast them anywhere. We're just using them as they are.
Yeah, we're referring to them as their base shape, their base or their existing type.
So look what we do here. Now I'm going to start casting them. Now I'm going to call base class. I can't cast that to anything. That's the simplest of all. I call name. Hopefully I'm going to see the same result of base class. But then I can call the derived, and I'll call name, and we'll see it's going to be very similar. But then what I can do is I can take derived new, cast it down to base class, and call name. And I can do the exact same thing to overwrite. That's where it's
Actually, why don't you cast
potentially a
the
surprise.
derived override to a base class as well?
All right, let's do them all. So they all go back. Oh, here we are. They all
How
go.
finicky it is. You can't change code whilst it's running. Cool.
Yeah, the day will come. Well, you can't. Well, yeah, right. Okay. So here's the surprise. All three call from inside their own implementations, but now when you cast them back to base, 3 of the 4 actually execute what is defined and implemented in the base, not what's in the class themselves. And let's remember which ones they are. The first one, let's see, the second one is using new, yes, the second one is using new. Am I in order? There we are. Sorry. Yeah. The first one is
using override.
the first one is the base. There's only 3. Sorry.
Yes.
Yeah. The first one is using override, which is what you want to happen. But the last 2, new and kind of implied new.
Yep.
Both, when you cast them back to the base, act like the base only, and they lose that implementation of the derived class.
So what this is really showing is the power of virtual and the power of specifying that we're overriding that virtual method. Because what it does is it says, we wish to replace the implementation that is on that base class, and even if we cast back to the base value, i.e. even if we use the derived override as a instance of the base, we still wish our overridden method to be used in place of the one defined in the base.
Yeah.
We cannot do that if we declare new. That only works if we're using them as their existing type rather than casting them back to their base.
Now,
and I see a lot of people tripping over this.
It's an easy thing not to see at design time or at dev time. I mean, you just expect the behavior that doesn't happen.
Exactly.
And it's just a misunderstanding of how virtual works. Probably a very common one.
Yeah. The Visual Studio actually helps with implementing overrides. If you type the override keyword and hit tab, then you get a list of methods that have been marked as virtual that are available for you to override. That's the power of IntelliSense.
I'll tell you what's really powerful. So in slide 26 is we begin talking about generics, what has to be one of the most powerful pieces of, and new to C# just a handful of years ago, that allows us to reduce our code, right?
Yep.
And the reduction of code, again, there's a lot of benefits to it, but generics is special. Generics allows us to take a type and say it's going to interact with another type, but we don't know what that type is going to be when we make the definition of it. It's very powerful. What do you see with generics?
So generics, as you say, are really powerful, and I loved it when they came in C# 2.0.
Right.
I kind of mentioned the idea of this templated reuse of code, that you may have an algorithm that transfers across a number of different types, but there was no easy way to do it unless you had this base in class inheritance and so on and so forth, and you had this common object root, and then you specified that your method would receive this common object root, and you would manipulate it that way. With generics, it's possible to design classes and methods that defer the type specification until you're actually creating an instance of the class or method within your code. So one of the most canonical examples of this has always been around collections.
Right.
Prior to the introduction of generics, we would write an awful lot of code to ensure that a list only contained
Poodles. Yeah.
You know, because by default, the
No doubt this was a big push for code generation too.
It was.
We're like, golly, I'm writing this collection over and over again. All I have to do is change the word, dachshund to poodle.
Yeah.
Surely I can have something build it for me. And what happened is, sure, you may have code generation, you may not, but what happened is you ended up with millions of lines of code.
You did. A huge amount of code bloat, which really increases the impact on your development, because say for example you want to change the implementation of your list. Now, because you've had to create all of these specific list implementations, you've got to change it everywhere.
Yeah.
Which is a pain in the backside.
Yeah.
So the language designers recognized that, and they introduced the concept of generics.
Now I'm looking at the code sample, and it's clear enough, right? At the top is the array list. I'll bet a lot of developers have forgotten the array list.
Yeah.
It's just one of those things that, especially because of generics, we just don't get into anymore.
Exactly.
But array list is just a list of objects.
Yeah, it's kind of, as the name suggests, it's similar to an array, which tends to be constrained in its definition, that you create an array.
Has an add method and things like that. It's very powerful. And so an array list, remember, everything inherits from object. That means I can put absolutely anything into an array list. And so the array list at the top allows me, I could put 1, which is an integer. I could put 2, another integer. That's what I expect. But I could also put the string of 3. And so now I've introduced a new type, but because everything goes back to object, it's okay. Right?
Exactly.
Because it's a generic kind of list. Now, the second sample is really cool because that shows the implementation of list that is generic. And so it's dangerous, I think, to use an array list because you never know what you're getting into.
You don't know what it is.
As you iterate through that list, you always have to check. Is this really an integer? Then I can use it like an integer.
I mean, what you've got there is the declaration, the variable name, objects, tells you that it's going to be objects. But say you turn around and said the variable name was dogs, you would imply from the variable name that it only contained dogs. So
Right.
when you took it out and tried to cast it from an object to a dog, and it threw an exception, you're in a lot of trouble.
The developer is really at the victim of this.
Exactly.
Generic solves it. It allows us to say it's like an array list, we just call it a list. But now you can see those brackets there defining that the internal members are only integers.
Exactly.
And so now, not only can I trust what is inside it, but I also can't start goofing around with it. You can see that the underline in red there is Visual Studio telling us that that list can't take a string. And what's beautiful about it is where before I might have I would have passed compilation, would have built, my testers would have discovered the problem. Now I can discover it at compile time.
Exactly. One of the other key things that we kind of brushed on a little bit earlier on is this concept of boxing and unboxing.
Yeah.
And generics really helps with this as well, in that boxing may be a little bit difficult to get your head around initially, but it's the idea that you have value types and you have reference types. you can take a value and treat it as an object.
Right.
And when you do so, that is called boxing.
Yeah.
Now the problem with that is that takes time. That takes effort from the runtime environment in order to take a value type, create an object, and copy that value into that object. And so there's computational effort associated with that. The other challenge is it can get complicated to track what's going on with that. So if we look at the example here on the right hand side, we have a value type of int count, which is equal to 1. We've created an object called count object. We then assign count to count object. Now from the developer's perspective, that's a simple assign. How hard can it be?
Right.
The
And we know
compiler,
an assignment is saying now they're the same thing.
Yeah.
But it's not.
But to the compiler, it goes, uh-oh, count is a value type. I cannot just assign that value type to an object because an object is a reference to an object. So what it has to do is it has to create an instance of an object and then copy the value of count inside that object, and then set count object to point to that object in memory. Okay?
It's brutal. I mean, you really are looking at two objects now.
You are.
You want to change the value, you got to change them
You've
both.
at least doubled the memory space associated with it.
Which is really getting to the danger of not understanding boxing and unboxing.
Exactly, because if we imagine you're doing this inside a loop that was being run 100, 1,000, 200 times. You're doing that overhead every iteration through that loop, which is a bad idea.
Right.
The other thing is you've now broken the relationship between count and count object. If we increment count, so we're using the plus equal syntax here to turn around and say count equals count plus 1, count is now equal to 2. But because there is no connection between count and count object is still equal to 1, which was the initial value that was copied in.
So
that may be counterintuitive when you're just thinking about things from an object perspective.
Oh, it is. It absolutely is, because I think everybody thinks reference types. In their brain, they are always thinking reference type.
Exactly.
And I think it's fair to say sometimes you have to box and unbox.
Sometimes you have to. What you need to be is strategic about when you do it. Don't put it in the middle of a loop and so on.
So what we want to avoid is boxing as much as possible, and that's kind of where we get to generics.
Yeah.
Generics allow us to not have to reassign values, because what we're really doing is saying this is a type of types, and we're going to interact with it later, right? And so I can define my class, I can define my interface, I can define my method.
Okay. We actually got a question that came in that was asking us about a practical reason for overriding. Can you think of a practical scenario for an overriding method?
I can, because what you could do is you would build let's say you build a base class that interacts with a database. And there really is a generic way to interact with a database. So you have a handful of methods. But then you build a derived class that inherits from that and uses all of that niceness that you gave it. But this one type of database really has to be interacted with this special way. I have to override and throw away the implementation in the base and make it completely unique when I interact with it when I'm interacting with this type of database. So that's a practical use of override, where it is imperative that we throw away the implementation in the base. Another
key scenario could be where we need to do something incremental to what the base does in that scenario. So we could actually have an overridden method that implements, say for example, we have dog and poodle, and a regular dog we don't shave, but a poodle we shave.
Right. So you have a take care of method.
Exactly. And so there's a basic take care of, which takes your dog for a walk and feeds your dog.
Yeah.
And all dogs have that. But with a poodle, when we take care, we shave as well as do whatever is going on walking and feeding.
If you don't override, then you create a scenario where you have a poodle that never gets shaved.
Exactly. So we could override that method, and then within that override, we could then call the base implementation using the base dot
and screw everything up. You got to be careful so that override allows you not to screw everything up.
Exactly.
It says no matter how they cast it, obey this pattern.
So hopefully that answers that question. We'll come across it in many other scenarios as we go through the day, for sure.
Yeah. So when we talk about defining generics, let's jump to the breakfast example. It's a pretty good one, where we have some simple inheritance. So at the bottom it's good. So we have offspring, and we have both an egg and a piglet. They're both a type of offspring. They really are.
Absolutely.
I mean, we don't know what they belong to, but we're preparing it. So you can see we have the egg class and the piglet class.
So I noticed that the offspring class is marked as abstract.
It is, because I don't want to, there is no such thing as offspring, but there is such a thing as an egg, and there is such a thing as a piglet.
So we're using the offspring class really to group things.
We are.
And so they're associated.
That's right, and that's important when we get to generics. Because if you don't have some commonality between them, you have to fall back to object.
Exactly.
We don't want to fall that far back.
And a generic class that can just do toString isn't very useful.
It's true, it's not. Good. All right, so here we have the breakfast method, and the breakfast method creates two things. It creates both a bird and a pig. What's cool is what it's really creating is an animal, and the animal then is a generic type class that's asking, you can pass in the type, and the type is really asking, what type of offspring does this animal have? So cool. I'm passing in, as I create the bird, I'm passing in an egg.
So why couldn't I say pass in dog to animal?
Well, this is important because I don't want to, first of all, that would just wreck everything.
Yeah,
I mean,
I have that for breakfast.
I mean, good gravy, the whole time-space continuum thing. So the reality is I want to be able to constrain it. So generics say, pass in the type and tell me what to do with it. But the where clause allows me to say, this type is going to be of a certain implementation. It could be a specific base class. It could be an interface as well. I mean, there's a lot of ways to constrain it, and you would want that, right? You don't want to pass a dog in as the child of an animal. You want to pass a puppy, let's say. And a puppy would surely implement or inherit from offspring.
Yeah.
And so because we've constrained it to where to offspring.
We're not advocating a puppy for breakfast.
No, we aren't. Let's be clear that this is the breakfast sample, and in no way are we eating
puppies.
Puppies. That's right. So now we've created a bird, and bird is a strongly typed animal that has offspring of type egg. It's very powerful.
It is.
Because now, I mean, imagine if I were to do this any other way, I would have to fully implement dog. I mean, sounds gross. The fully implement bird, fully implement pig in order to have that.
This is a bad scenario.
Why'd you bring up dog? Oh, it doesn't matter. Anyway, so it's nice because look, I can define this class now in 3 lines.
Okay.
A lot of goodness there. All right, let's look back.
Let's look back. So that flew by. And during that time, we went through the scenarios of how you would create complex types, how you can interact with those types.
Keywords that make them very special.
Exactly, how you can constrain interactions with them, when they can be instantiated, if they can be instantiated at all.
Right. And some you don't want to be instantiated, including static.
Exactly. Then we also talked about object interfaces and inheritance and kind of described how we can share behaviors from a base through all the derived classes.
Or define a contract that describes what that object is, but doesn't offer its implementation yet.
Absolutely. And then we talked about generics and the power that generics provides. And again, we can only lightly touch on these things. There is a lot more to learn and a lot more to do with generics in terms of you can create generic interfaces as well as generic base classes and so on. It's a very, very powerful topic.
It's not that you need a lifetime to master, but you probably need more than the 10 minutes we gave it.
Absolutely.
Absolutely, no doubt. All right, that's it for this module. We'll come back to module 3 in 10 minutes. And between now and then, go take care of business.